So now we're going to look at some additional rules for naming ionic compounds when we change them up a little bit. So let's talk about what we call polyatomic ions. So polyatomic ions are going to be ones that form from more than one atom. So we call them polyatomic because we've got a bunch of atoms combined together. And the most common ones we're going to use in this class are on the table on the right. Now you may notice I have them in two colors. So what I'm asking for this class is that you memorize the ones highlighted in blue. This means memorizing the name, how many elements there are of each type, and the charge. We are going to use those a tremendous amount, and you're likely to see them in future classes. That's one reason I've picked them. For example, as a biologist, you'll see a lot of phosphate. That comes up a lot. No matter which of the sciences you work with, you'll definitely see hydroxide. Honestly, as a chemist, you'll see a whole bunch of these all the time. And really, even the ones I haven't highlighted, you're likely to see sometimes. But I think if you only came away from this class knowing a few, these are the ones I would like you to know the most. Now, if you use any of the other ones, other than the ones highlighted in blue, on a quiz or a test, I will make sure there's a table at the front of your exam that reminds you of what these are, so you can look them up. But memorizing those in blue will help you tremendously with being able to do problems more easily. And as you'll see when you're naming compounds, being able to recognize them inside a compound is very important and part of how you work with naming compounds and identifying them. So how do we name an ionic compound with a polyatomic ion? So if we have an ionic compound that has one, it's going to be named very similarly to the binary ionic compound. All you're going to do is you're going to replace where the atom would be with the polyatomic ion name. So if you had an anion that was polyatomic, you would stick it in there, and the only difference would be you don't have to add an IDE ending like you do for anions that are just elements. So let's take an example from earlier, from type 1. Let's say you had sodium bromide. That doesn't have a polyatomic, so you just name it that way. But let's replace the bromine. Let's say you replace the bromine with NO3, which is nitrate. Well, now it would be named sodium nitrate. The sodium doesn't change. And since we have NO3 there instead of bromine, we now put nitrate in the name. If it were type 2, you would have a Roman numeral. With type 1, you don't, just like with the other binary compounds earlier. So if the polyatomic ion in the compound name is negatively charged, it means it's going to go at the end. Because remember, that's where we put the anion, or the nonmetals when we were doing them if they were just two elements. If it's a positive charge, we're going to put that at the start of the compound. The only one we're going to use in this class is going to be ammonium. So if we go back to our table, and then we can see that only ammonium up here has a positive charge. We have way more negative polyatomic polyatomic ions than we do positive. We only have this one positive one that we use commonly. Although we do use a fair bit of ammonium in different compounds. So the main challenge is going to be knowing the polyatomic ions well enough that you recognize them in naming a compound. So when you see NaNO3, it's about being able to look at that and know, oh, NO3 should be grouped together. Because at first you might be like, oh, it's Na and it's N and it's O3. That's got three different things in it. I don't know how to name something with three different things. So being able to recognize that is the main challenge in these. Once you recognize it, the naming isn't usually too bad. So here, we're going to look at how we name these compounds. So I would suggest looking at that table I have 2 slides ago, maybe making some notes of the ones you really need to memorize, and then using those to try naming these. Because I know you wouldn't have them memorized 2 slides after I did them. So give them a try. Okay, let's take a look at what you would have gotten. So here we have potassium, and then we have nitrate. We name it as a type 1 because potassium is in group 1. Next we have Mg connected to NO2. So Mg is magnesium and it's in group 2, so it's also a type 1. So we have magnesium nitrite. We then have Ru, which is ruthenium. Make sure I got that. Yeah, ruthenium, which occurs in your transition metals, so it's type 2. So I have to worry about its charge. And then I have sulfate. So just like before, sulfate, we have to think about its charge. It's -2. So we have 2 rutheniums, and we're adding to that 3 times the charge of sulfate, which is -2. That has to equal 0. So 2 rutheniums minus 6 equals 0. So 2 times ruthenium equals +6. I divide both sides by 2. I get the ruthenium charge has to be +3. So that means, I'll be honest, my ability to spell ruthenium is limited. I'm going to have to check this. So that's how. I will tell you I've not used this element as much as some of the others I use. So let's see. Ruthenium. And then it's going to be 3, and that'll be sulfate. I'm trying to remember the spelling, if that's a PH or an F. I suddenly forgot for a second. Okay, that is an F. I don't know why I wanted to put a PH there. My brain. I am recording this kind of late tonight, I'll admit. Just trying to channel my inner student, right? Doing this late at night, just like we tend to do our homework and quizzes. So now, for our last compound, this one, we have ammonium. Ammonium only takes a +1 charge, so we can name it like a type 1. Although if you put a Roman numeral, I wouldn't count off. So this would be ammonium bromide. So we still name the secondary element part the same way as before. So that's what we can do with polyatomic ions. And let's see trying the other direction. So I want you to try these two. Try to come up with the chemical formulas for iron 3 hydroxide and sodium phosphate. So now that you've done that, let's try the first one. So here we have Fe has a +3 charge. Hydroxide, once you've memorized it, you'll know that FOH is -1. So to balance this out, I need multiple hydroxides. I'm going to need 3 of them. So I'm going to put Fe. I'm then going to put the OH in parentheses since it's a polyatomic, and then put the 3 on the outside of it. The reason I do that is this parenthesis says you're supposed to triple the O's and the H's. And the polyatomics behave like they're going to act similar to a single element, so they're always going to be together. So if I have 3 hydroxides, I need to put a 3 in parentheses. If I just said FeOH3, that would be wrong, because that would give me 3 hydrogens, but still only 1 oxygen. We then have sodium phosphate. Sodium is always a +1, and then phosphate is a -3 charge. So we're going to need multiple sodiums to balance out this -3. I'm going to need 3 of them, because that'll give me +3 and -3. So this will be Na, and I'll have 3 of them, and then I'll have PO4. Since there's only 1 phosphate, no need to put parentheses around it. So that's how we deal with the polyatomic ions. We have one more adjustment we can make, because sometimes we will have water molecules associated with our compounds, and we call these hydrates. So a hydrate is going to be an ionic compound that also contains water molecules associated with each formula unit. So for example, MgSO4 with this dot thing here, and this dot means hydrate, and if we connect it to 7 water molecules, we get the formula for Epsom salts. So in chemistry, the way we would name what I just wrote is magnesium sulfate heptahydrate. So what you can notice in the naming is that something that includes water doesn't change the start of the compound. So this MgSO4 part, we don't change how we name it. So magnesium sulfate is how you would name MgSO4. But what you do is you change it by adding the word hydrate at the end and a prefix to account for how many waters there are. So I realize I just made the line show up now. So I'll repeat myself. So when your compound's a hydrate, you include the word hydrate at the end. You don't have to do anything in the middle. And the prefix you put in front of hydrate tells you how many water molecules there are. So to do this, we have a set of prefixes. You should learn these and have them memorized. You will probably have seen a number of them before. The only one that really tends to stand out to people is this one hemi here, because hemi stands for 1/2. You can have a setup where you actually have fewer water molecules than you do the rest of your ions, so we'll use the hemi prefix in this case. So you'll end up with a hemihydrate sometimes. But the rest of these are ones you will hopefully have seen somewhere before. And on top of that, even if you haven't and you have to memorize them, we're going to use them from other naming conventions as well. So it's not just for doing it with water. So there'll be some value to that. Now we've looked at this, let's look at how we would name these. So I'll do the first one. So the first one, calcium, it's a group 1, so I don't have to worry about Roman numerals. We're going to end up with calcium, sulfate, and then we've got a dot 1/2 water, so that's going to be hemihydrate. So we just add a 3rd word onto it. So now you try the second one and the third one. Okay, let's look at what we would have gotten. So strontium. Strontium is going to be, we should check our periodic table. Strontium's in group 2, so it's a type 1, so we don't have to worry about our Roman numerals. So we have strontium chloride, strontium. That's a poorly spelled Strontium. The I kind of got weird. Chloride. And now we have 6 waters, so that's going to be hexahydrate. Now for the third one, Copper is going to show up in our transition metals. So we have to name it with a Roman numeral. So we'll have copper 2 because sulfate is -2. So to balance it, copper is going to have to be +2 because there's only one of each. So 1 minus 2 is balanced with 1 plus 2. So we have copper 2, sulfate, and then we have trihydrate. So that's going to be how we would name our hydrates. So these are the two other types of ways we can do naming where we can add extra things to ionic compounds. We can either use polyatomic ions that change the naming of it, or we can have waters associated with them, which then we need a third word to represent how hydrated the compound is. In our next video, we'll be exploring covalent bonds because we've covered all the naming we're going to do for this semester on ionic bonds in this video.